Hey guys, what's up and welcome back to this new video. So in this video I will show you how to make a water stream in 3ds Max, a continuous water stream water simulation. So we'll start here now. So first of all I will just make a water path. So for that I will start with a box and I will make a detailed box. So I will just increase the segments on this side and here also. Okay, now I will just make it bent. So bend and yes, like that. Okay. I will just, so the thing is, what I am doing is I will just make a bend in one place only. You can do that like this. So I just change this. No need of changing this or that. That is the one that I'm trying to do. So that's it. Now I will just make borders for this. So come down here to edit poly and select the sides. Okay, and now extrude it. All right, and move it up. Okay, now just make a little noise in the surface, a little disturbance, ups and downs. So I shall selected that. Now apply noise. All right. Okay, that will be enough. Okay, now what I am doing is just tilt the surface. So I selected that and now select smooth. So you know what I'm doing. So the water flows down from the front side. If you see, if the water comes, so it will spoil outside. So I will just to make it banking, remove the banking. That's it. What I am just doing is making the surface of the water. Okay, I think that is enough. Now I will just make a water from where it will start. So here you can see there is called fluids. This is already built in the 3ds Max. So just make it. Okay, what is that? Forget it. And now this is the start of the surface. So here I will just make a box. So from this the water will generate. You have to make it of the correct size, correct scale. Just if you see this stream, what is the scale of this? So if I just measure it, This is just I made it roughly. So what is the length? 285. So in the water simulation, this 285 means 285 inches. So what is the, just think, what is the common size of a water stream? What will it be? Is it near to 300 inches? If yes, then okay, then it is fine. So the proper scaling is necessary. So I think just we will just make it like that. 285 inches. It is quite a big size, man. Yes, it is okay. So now I selected that, and in the simulation view you can see here icon type custom, pick that one, done. Now collider, this one. Now come down to here, simulation parameters, master voxel size, increase it like to 2, which will speed the simulation, and turn off this, I don't like that. So increase the time steps values, just make it 6, and that adaptivity is 0.2. This is for the reason that water particles do not go through the surface. It takes more time for simulation, but the result is better. Okay, all right. Now here you see 1 unit is equal to 1 inch, which means that this is 285, so this stream will be 285 inches. So 285 inches is about the size wall length of a common room, so it's okay for now. Okay, now we just need to simulate it. So press here. Okay, will it go down or it will stop it there? Whoa. See, that is happening, but it's okay for now. So the water is flowing down. Later I will insert here a stone or a rock. Okay, and for your information, it's not like the size of a river. See, 285 inches is not the size of a river. This is just like a water slide in the playgrounds. You got my point. Hey guys, you can share this stream on your channels and it will be really nice. Come on and do comments and subscribe also. Okay, so we are about 61 frames complete. Okay, how much. Why is there some space missing? The reason is that hmm, the reason is that place is higher, that's it. Or the reason is the water quantity is less. So what you can do is, here is the emitter, and you can see this is called the expansion rate. So if you increase it, the water will produce more fastly. If you decrease it less than 0, water will be slowed down. So more water, which means more of the space occupying. But for the moment this water is flowing down, and here it will get out of this surface. So in here there is the display. In the display, this is the point. So we are just viewing the points. Color, what will be the color? Color depends here on the vorticity. You can change it to velocity or to whatever you like, available here, to the density, to the curvature. So see, what I did is, when I started, select custom emitter, that one you select it from here, pick and select. Now here is the collider, the surface on which the water is flowing, pick, and that one, that's it. This is finished. Now come here, simulation parameters. This is simulation parameters, it's just not visible there completely. So here I increase the save solver properties, ignore the other settings for now, and increase the steps here. Simple as that. Now liquid parameters, here you can select different kind of liquids. By default it's water, and that's it. Don't go to the other settings. When you just come here and select water, that's it, just simulate it. Okay, so it's about to complete 100 frames, and that's it. Come on, come on. Yes, alright, now let's play it. That flowing down really looks bad, man. I'll just hide it. Okay. Now the next thing, water is done, so we will how to render it. So in here you can see dynamic mesh. It is point, we are viewing only point. So if you select dynamic mesh, it will just make a mesh geometry from that. It is actually a geometry. See, there are vortices, so it will play. If you start the animation, it will just play. After a few frames it will be completed. So you just keep on playing it and it will just buffer itself. So here from the water flow you can observe what scale you have used. Let's just assume if it was a dam. So will the water flow with this speed? Of course no. So it's not a dam. You make this so it makes sense, right? With what I mean is, you have to use proper scale. If you have made it very big, so of course the water will flow slowly. You will say, why is it not working? Now what I will do is I will increase the water amount, and also just put a stone. Noise. Okay, it will be 20, 20 and 20. Okay, I'll just add one more. Okay. So now what I will do is I will just convert it into a big river. So what I will not just increase the scale. I will just go to water, and here in the simulation parameters change it. 1 unit is equal to 1 inch, so make it 1 meter. So what mean is this was 285 total, so now this is 285 meters long. So 285-meter long will does mean that it is not just a water slide, it is a river. So now if you simulate it, you will see different results. Let's see, in 100 frames, in 70 frames it reached this edge. Now it will not reach with that time. Okay, here I did one mistake. I changed it to centimeters. It should be meters, man. Okay. So you can see now it takes so much time while falling down. So I will change the scale a little small. Okay, just to make it 0.25. When this water will hit this stone, it will make a big mess. It is a huge mass now. Come on guys, make some comments. On this scale, I will just display something like this will be a car for this scale. That is a car. The scale that we used, so a real size car will be that much big, and that is water coming. Or even smaller than this, a real size car standing there. Come on. Okay, it's finished. So for larger simulations, for large scale simulations, you have to use also smaller this one, which means that 0.5 or even less than that, and which will make water simulation slow also. So we will just stick to the small scale simulations, which is like this, same as before. So water will flow fastly. What I will do is I will just increase the speed of the water. Now let's start. So it's back to same size, just a water slide. And more water also. Man, this is too much water. It's flowing down. Because I increased the expansion rate. Wait, I didn't edit these as the collision. Let's stop it. Okay, resume. Okay guys, so the first person who comments, his name will be here. Come on, who will comment? Anyway, the simulation is going and the water is flowing out. But I want a person who will comment first. AUM Kansara. Okay, AUM Kansara. Hey man, where country you from? Whoa, 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 whoa. It's too much water. So I will just stop it for now because the water is overflowing, man. So for that, just decrease it. Restart. From India. All right. India. So do you know which country I am from? I hope you can guess from my voice. Hmm. Alright, I think now it's coming correctly. Let's see, is it going down? Yes. And I think again it will overflow. Why is this, man? Why? You know everything, man. Pakistan, Peshawar, Qatar. Which place in Peshawar? I am from that place and I am now in Qatar. Okay, I think that water is now okay. It changed the direction. Norwegian crazy gamer. Hey man, what's up? So now you see the water reached to the border very fastly. Before it was 70 and still also it's 70, man. Anyway, my bad. Well, for the stones I thought it will just stay in the middle and the water will flow on the sides, but the water is covering it, which means the water is too much. and this time the water will overflow at the end. The rocks look like chicken nuggets. Yes. Well, anyway, because they are rocks, the shape, the color looks like chicken nuggets. Yes, you are right, man. Now, come on, finish it. Wow, here there is something happening. This this stream of water is very distorted, man. The water flows very angrily here. Here also on one side it's loaded up. Here also on one side it's loading. And those stones. Okay, it's completed. So now let's watch it. It will buffer now. Come on, play. Hmm. Okay, so now how it looks, guys. Do comment below. I know there is no material now, but okay, so that is how it works, guys. In the next video I will show you how to apply materials to it and how to render it correctly. And there also is one another thing. You can create the upper bubbles onto this water. So we'll do that in next video. So for now, that is how it works, and I will continue this in the next video. So thanks for watching. Leave a like and subscribe to Spectaman channel and share this video, why not. Okay, so thanks for watching and see you in the next video. Goodbye.